Welcome to qnawire.
So now we'll work on problem 75 from chapter 13. So one note to make, the solution that we're working with in this problem is 28.8% iron chloride, FeCl3, not ammonia, and the density is equal to 1.280. Grams per milliliter. So that's what's given in this problem, and we need to calculate molality, molarity, and mole fraction. So we can follow a similar process as we used for problem 74, where we calculate all the different parameters that we'll need to calculate these three concentrations. So we start with mass of iron chloride. We know the concentration, or the mass percent, which is 28.8%. So we just choose our total mass of solution as 100 grams. And then we multiply it by this decimal, or this ratio of 28.8 to 100%. And that gives us 28.8 grams of iron chloride. So we can easily calculate mass of water then, because our total solution is 100 grams, and then if we subtract the 28.8 grams of iron chloride, we get to 71.20 grams of water. So with these two values, these two masses, we can calculate the moles of both substances. So first, moles of iron chloride, and all we have to do is multiply, or we take the mass, 28.8 grams, and then divide it by the molar mass, which is 162.20 grams. And that gives a value of 0.1776 moles. We can do the same thing for water. We take the mass that we have, 71.20 grams, and divide it by the molar mass, which is 18.02. And we get a value of 3.9512. And then the last value that we need to calculate before we calculate the concentrations is the volume of solution. So all we have to do there is take our assumed weight, which is 100 grams, and divide by the density, which we're given. And this was given here and in the problem. And we have to, of course, keep in mind that we want volume in liters, so we do 10 to the negative third liter times milliliter, or divided by milliliters, and we get 0.0781 liters. So those are the values that we need. Let's calculate molality first. So for molality, we need moles of solute, which is moles of iron chloride, which is 0.1776 moles divided by the mass of the solvent in kilograms. So we calculated it to be 71.20 grams. And we just need to throw in our conversion so we can convert from grams to kilograms. And we get a value of 2.49 lowercase m iron chloride. For molarity, we have again the same numerator, 0.1776 moles. This time we're going to divide by the volume of the solution. Excuse me, I don't know why it's shooting up like that. So the volume here is 0.078 liters, 0.0781 liters. And so we do this division and we get a value of 2.27 big M for molarity iron chloride. Finally, we calculate mole fraction. Again, the same numerator, 0.1776 moles divided by the total moles, which would be 0.1776 plus the moles of water, which we calculated here as 3.9512. So we do this calculation and we get 0.0430.